for A is the gradient minus 3x.
Yep.
And
Y-intercept?
2.
Yeah. How about B?
Well, to work out B, you want to plus 3y on both sides.
Yep.
So it'd be 4x add 5 equals 3y. And then do you divide both sides by 3?
Mm-hmm.
Which would give you y equals... So when you divide the 3 by the 4x plus 5, would that be 4x plus 5 over 3?
It could be. And another way to write it is 4 over 3x plus 5 over 3. So you can do the two separately. It's the same thing.
And then would you simplify it?
We just need gradient and intercept.
Okay, so the gradient is 4 over 3x and the y-intercept is 5 over 3.
Yep, that's it. Gradient 4 over 3, intercept 5 over 3. Great. Yeah. So it's when it's in the form y equals. There we go. Okay, any idea what's meant by this? This one. Just make it equal to 0 and make them not fractions or decimals, basically.
So would you minus y on both sides?
Yeah.
So it'd be 4x plus 3 minus y equals 0.
Yeah. And B?
Okay. Would you also minus y on both sides?
Yep.
So it'd be minus a half minus a half x minus y plus 5 equals 0.
And what they should have said was where a, b, and c are integers. So how could you make these whole numbers? We have a fraction here.
So would you simplify the fraction so it'd be 0.5?
Still not an integer. Just written a different way. What would you have to do to a half to make it a whole number? Make it not a fraction.
Would you divide it?
Divide by?
2.
Times by 2.
Okay.
You could divide everything by a half or times everything by 2. Great. What do you get?
You get minus x minus 2y plus 10 equals 0.
Well done. And that is the same as if you brought everything to the right side and got plus x plus 2y minus 10 equals 0. Both of those are correct.
Yeah.
Let's see what old Bookie has to say. Yeah, so that one, x plus 2y minus 10 equals 0. So often it's unwanted to have a fraction or decimal, and so you make it equal to 0 and multiply by the denominator to do that.
Yeah.
Here we had 2 minuses and 1 plus. You often change it to be 2 pluses and a minus, but there's no, you don't have to.
Yeah.
Alright, how about this?
Okay. So would it be so when it meets the x-axis, would the y coordinate be 0?
Well done.
Okay. So would it be 2?
Yeah, got it. X equals 2. And so as coordinates?
It would be 2, 0.
Great. 2, 0. So this is the stuff people have difficulty with. You're trying it. Let's see. That might be worth doing, that one back there. Yeah. Let's see. let's try to skip to all the way to this. Okay, any idea about this?
Okay. So we know the gradient is 5x, so y equals 5x.
So do you know how to find the gradient?
Is that the equation?
Yeah,
Is it
y2.
m equals? Yeah.
So try that. Sorry, just getting a call 1 sec.
Okay.
Sorry about that. So what did you get there?
2 minus 0 over 0 minus 5,
Yeah.
which is minus 2 over 5, which is the gradient.
Well done. And we want the equation of the line. How do we get that?
Okay. Don't we need the... Oh, we got the y-intercept, which is 2. So it'd be written out as y equals minus 2 over 5x plus 2.
Okay, and they want it in this form.
So you minus y on both sides. So it'd be minus 2 over 5x minus y plus 2 equals 0.
And what they should have said was where a, b, and c are integers.
So then you multiply by 2 over 5. Would that be right? Oh wait. Let me see. So would you multiply by 0.4?
For the previous one, we didn't multiply by 0.5. We multiplied by the denominator 2.
So would you multiply by 5 then?
Yeah, because that gets rid of the divide by 5.
Okay, so it'd be minus 5. Wait, that would it be minus 5? For minus 2 over 5x. Or should I do it I can do it in the calculator times.
Calculator, yeah.
It's minus 2, so it'd be minus 2x minus 5y plus 10 equals 0.
Well done. And you can also write it as 2x plus 5y minus 10. So you have only one minus. That's like if you'd multiplied everything by minus 5, I suppose. Or then multiplied by minus 1. Great. And that's something that comes up a lot. Let's see. And I'm glad, because there was lots of questions before that are similar.
Yeah.
But that's the exam question. I'm not doing that. Okay, exam question. That's same. Yeah, it's the same.
Okay.
And in fact, let me just make a note to myself. This one, this is arguably a bit easier, so maybe that needs to go back. The point P. Okay, let's try this.
So what is point P?
Where they cross over.
Like the y-intercept?
So you've got like two lines.
Yep.
And where they cross over is
section. Okay.
And you have to find the coordinates of that point.
Okay, so for the second equation, are you supposed to convert that back into like y equals?
Don't have to.
Okay. So for the first part, it would be y equals minus 2x plus 6.
Yep.
And And then would you minus y on both sides?
You could. What would you do after that? You have to find where these two lines cross over.
Could you put it into the calculator as a wait, no, you can't.
So we want to find out where they have the same x and y. At this point P, x and y are the same for both of these.
So do we have to like make them the same, like both equations?
How would you do that?
Well, could for like
essentially you would have to solve them simultaneously. It's like simultaneous equations.
okay.
How would you do that?
So what's a better state for it to be put into the simultaneous equation like calculator, like the bottom one or the top equation? Which one's better for the calculator?
You need both. So there's two ways to do this. One way is this thing here is equal to y, and so you could replace that y with that.
So you'd write it out as 5x minus 2x plus, is it minus 2x?
It'd be minus 8 times.
Oh, right, yeah. Minus 2x plus 6, yeah. Minus 15 equals 0.
Yeah, and so you go from having two equations with two unknowns to one equation with one.
And then would you solve it? Would you expand the bracket?
Yep.
Okay. So it'd be 16x, 5x plus 16x minus 8 plus 5 by 6, 48 equals 0.
And don't forget your minus 15.
Oh yeah, minus 15 equals 0. And then you could simplify it.
Yep.
So it'd be 21x minus 48 minus 50 minus 63 equals 0. And then would you have to divide it by a number to simplify it or something?
You're trying to get x on one side by itself.
So you'd minus 21x on both sides.
You could, yeah. You could add 63 to both sides.
Oh yeah, add 63 to both sides. So it'd be 21x equals 63. And then would you divide by 21 on both sides? So it'd be x equals 63. Which is 3. So x equals 3.
Well done. X is 3. Is that full marks? Oops.
No, you need the coordinates.
Yep.
So we know it's x is 3, so it'd be 3 comma. So how do you know what y is?
Write 3 instead of x in one of your equations.
Wait, so would it be minus 8y?
Use the top one. Now we know x is 3.
Oh, so we substitute in. Okay.
Yeah.
So y equals minus 2 multiplied by 3 plus 6. So it'd be y equals minus 6, add 6, it's 0.
0. There you go. And so coordinates?
3 comma 0.
3, 0. Do I have the answer for this one? I don't. Alright, so it can be 0, fair enough. Yeah, 3, 0. One other way to do this one. So that way is the way that always works, and that's
Yeah.
the quadratic simultaneous equations method. We said y equals minus 2x plus 6. If I was to rearrange that, I could get 2x plus y equals 6. And rearrange the other one, I could get 5x minus 8y equals 15.
Yeah.
And then that's the that's the way the calculator can deal with simultaneous equations, but they have to be linear. Simultaneous equations, two unknowns, 2, 1, 6, 5 minus 8 and 15. And we get x is 3 and y is 0.
Yeah.
So we know we're correct. But that only works for two linear things. But hey, they are linear, so let's try this one.
Okay. Okay. So, we substitute minus 3 into y equals 3x minus 7.
Mm-hmm.
So it'd be minus 9 minus 7 minus, which is minus 16. So y is minus 16, so the b is minus 16.
So b is minus 16. How about a?
Okay. So, for that, to find out a, you need to use the equation ax plus 4y minus 17 equals 0.
Mm-hmm.
So, when it says 4y, does that mean that? Oh no, it doesn't work like that, does it? But it does. No, it can't be. I was thinking that a could be 4, but it can't because you don't know what a is.
Mm-hmm.
So would you write out as ax plus 4 and then brackets 3, and then would you substitute x in, which is minus 3? Would you need minus 3?
You might be onto something there. Hang on. So let's just write 3x minus 7.
And then minus 17 equals 0.
Minus 17 equals 0. But actually, yeah, this is the standard way, but your way is even... And actually, we know x and y. Minus 3 minus 16. So you could sub those both in instead of x and y.
Okay.
So what would you get for that?
So would you write out as a multiplied by minus 3?
Yeah.
Plus 4 open brackets 3 multiplied by minus 3.
What is y? At the point of intersection?
Minus 16.
Yeah.
Okay. Minus 16. And then minus 17 equals 0.
That's it.
So would it be... Would a multiplied by minus 3 be minus 3a?
Yep.
So it'd be minus 3a plus minus 16 minus 6 plus 6 minus 64,
Mm-hmm.
and then minus 17 equals 0. And then we can simplify.
Mm-hmm.
So it'd be minus 60. Minus 81. So it'd be written out as minus 3a minus 81 equals 0.
Mm-hmm.
And then you'd plus 81 on both sides.
Mm-hmm.
So it'd be minus 3a equals 81. And then you divide by 3 on both sides.
Mm-hmm.
Which would give you minus a. Would you divide by minus 3? Or would you just divide by 3?
Whichever. I'd go with minus 3.
Okay, so would it just be a then?
Yeah.
Okay. So it'd be a equals 27.
A is... Ooh, I got minus 27.
Minus 27. Let me check. So it was... So I got to the part minus 3a plus minus 64 minus 17 equals 0. Is that part right?
So let's see. So we have minus 3a, 15, 30, 45, 60. That's minus 64.
Minus 17 equals 0.
Minus 17. So you bring those to the other side.
And then you simplify it, so it would be minus 81.
And when you bring it to the other side, it becomes plus 81.
Yeah.
And so what is 81 divided by minus 3?
81. Oh yeah, it's minus 27.
Yeah.
So a is minus 27.
Yep. Great. That was not as bad as I thought it would be. Okay.
Yeah.
Gradient and y-intercept.
It's pretty easy.
Yeah, that one's alright. Okay. How do we do this?
So it has to pass through 2 and 3, the line.
Yeah, it has to go through 3, 2.
Okay. So we know the gradient. Wait, so what type of equation is it looking for then?
So, in general, what's the general form of the equation of a straight line?
Y equals mx plus c.
Yeah. And so far, we know the gradient is 5, so what can we fill in?
So it'd be y equals 5x plus 3c.
Okay, so we just need c. We know it goes through the point 3, 2.
But isn't 2 the y-intercept?
That would be if it was 0, 2. So x coordinate 3, y coordinate 2. How can we get c?
Could you minus it with another coordinate, or is that not possible?
Well, we know that when x is 3, y is 2, we could use that to solve for c.
So would you multiply 5 and 3?
Yep.
Okay, so that'd be 2 equals 15 plus c.
Yep.
You know the 2 would be written out as 2y, or just 2?
It was y, but it's now 2.
So could you minus 15 on both sides?
Yep.
Which would give you minus 13.
Yep.
Equals c, so c is 13.
And so what is the equation of the line?
Y equals 5x plus minus 13.
Well done. And so that's how you can find the c. In general, all straight lines y equals mx plus c.
Yeah.
Therefore, c equals y minus mx if you
Yeah.
rearrange it. That's one way to do it. 5x minus 13. Okay, how about this?
Okay. So you have to work out both coordinates separately, right?
Let me think. So I think that would work. Well, you need the gradient. I think your way is crazy enough to work. So hang on. Y equals mx plus c. So if you subbed in m and x, what would you get?
But you don't have m. You don't have the gradient.
If you subbed in x and y, sorry, what would you get?
Oh, okay. For 5, 7, so it'd be 7 equals m multiplied by 5 plus c.
And so that's like 5m plus c.
Yeah, 5m.
And the other one?
It would be minus 1 equals 3m plus c.
And if we were to write the equals on the other side, and so any idea how you'd solve that?
Equals 7 m plus c. Could you minus 5m from both sides?
You could use the old calculator. That right
Or
there.
could you use simultaneous equations?
Yeah.
So it'd be so would y in the simultaneous equation be 1 for c?
So yeah, m is like the x, c is like the y in the
So
calculator.
for c is 1, right?
I don't know.
So do we just leave it at 0?
I don't know. Hang on. Did you put it in your calculator?
Yeah, but what's c? We don't know what c is, but what do we just put 0 as c?
Oh, in the calculator would be 7 is the first one.
Oh, but it's equal to 7, equal to minus 1.
So 517 is the top
Oh,
one.
it'd be 1 then. Okay, 1,
Okay, yeah.
3. Then it'll be 3, 1, minus 1, which gives you x equals 4 and y equals minus 13.
4 minus 13. And so which is which?
Wait, what do you mean which is which? X is, so for the first one, x is 4.
Now we have m and c, not x and y. The calculator just says x and y.
Oh. So, okay. So, if we have...
It's just the first one. So this is the first one. This is the second
Oh, yeah,
one.
it's just the first one, isn't it? So m is 4.
Yeah.
And c is minus 13.
Yeah. And so equation in the line?
Y equals 4x plus... No, minus 13.
Well done. Y equals 4x minus 13. There we go. So they did it a much more challenging way, where they did y2 minus y1 over x2 minus x1 to get the gradient.
Oh, yeah.
And then they found
Yeah.
c. Yeah. Okay, so this looks very similar. This looks identical. Am I crazy? Yeah. That's a duplicate. Hang on. So for that one, we just use simultaneous equations by subbing in x and y. Let's see. Yeah. So try this one. I'm just gonna plug in my phone. I'll just be a second.
Okay.
So how you getting on with this one?
So I used the y equals, no, I used the y2 minus y1 over x2 minus 1 this time.
Okay.
So I got minus 8 minus 2 over 9 minus 7, which is minus 5. So it'll be y equals minus 5x plus c.
Mm-hmm.
And then we need to find out. So after this, do we need to like rearrange it to get c? Or we don't know what y is? Or c?
We do know what y and x are. We can take our pick.
Does it matter which one?
Just so long as you use the same x and y from the same coordinate.
Okay, so we substitute 2 equals minus 5 open brackets 7 close brackets plus y. And then you'd work it out, so it'd be 2 equals minus 5 times 7 is minus 35. So it'd be minus 35 plus c, and then you'd plus 35 on both sides, so it'd be 37 plus 37 equals c.
Yep.
So it'd be y equals 5 minus 5x plus 37.
Yep, and they wanted it in this form for some reason.
Okay, so then you minus y on both sides, so it'd be minus 5x minus y plus 37 equals 0.
Yep. And okay, so they seem to be building up to that, because usually they'd only put it into the equal 0 form if it's a fraction.
Yeah.
I'm going to try simultaneous equations for this. So we have x is 7, that's 1, and y is 2, x is 9, that is 1, y is minus 8, minus 5, and 37. Yeah.
Yeah.
Okay, great. This looks weird. I'm not doing that. This looks even weirder. The straight line, but it's an exam question. Yep. Better do this.
Okay. So is it better for me to convert the x plus 6y plus c back into y equals mx plus c?
It might be. The straight line passes through A4. 3A3. I would sub in A4 and 3A3.
Okay. So would there be two like equations? Separate equations?
Yeah, I think so.
So it'd be, so when subbing in a, would it be 4, no, it'd be ax plus 6y plus 4.
Maybe I'm being too clever. You can use your method of the y2 minus y1 thing, I think. A straight line L passes through these 2 points. This is the equation of L. Find A and C. Yeah, so I think you could find the gradient if you wanted. That's one way to go about it.
Okay. So should I sub in a4 first or no?
Yeah, go on, sub it in. What do you get?
So when subbing in, would a be ax or would it just be a?
Just A.
So it'd be a plus 6y plus 4 and the other one. Should I sub in the other one as well?
What is y? Oh yeah, 6, 4, sorry.
Yeah.
C equals 0. Yeah, and then the other one?
We'll just be writing out as 3a plus 6 3 plus c.
Plus C equals 0.
Yep. 6. And then you'd work it out. You'd like expand the bracket.
Mm-hmm.
So it'd be 3. Well, for the first one, it'd be a plus 24 plus c equals 0. The second one would be 3a plus 18 plus c equals 0.
How'd you solve for A and C?
Would you... So could you minus 24 on both sides?
Yep.
So it'd be a plus c
Yep.
equals minus 24.
Mm-hmm.
And then how do you work out both though? Because there's only one number, which is 24.
Do the same for the other one.
Okay. So it'd be, this other one would be 3a plus c equals minus 18.
Mm-hmm.
What, and then we just put that into the calculator?
Yep.
Okay. So it'd be 1x, 1y equals minus 24.
Mm-hmm.
And then, so for 3a, would you write it out as 3 brackets 1?
It's just like 3x. You just do 3.
Okay. And then plus 1 equals minus 18. And x equals 3. Y equals minus 27. Or in our case, A equals 3. And C equals minus 27. I think.
A
A equals 3, C equals minus 27.
equals minus 27. Yep, looks good. Great. Maybe I'll just do check 1, 1, minus 24. 3, 1, minus 18. 3, minus 27. Yep, great. There's lots of ways of doing it. You could have done y2 minus y1 over x2 minus x1.
Yeah.
That would give you the gradient. Well, that would give you the gradient in terms of a. So,
Yeah.
So like 1 over minus 2a. But then that would be equal to minus 1 over 6. If you were to rearrange this equation,
Yeah.
you would get that. And then you could solve a like that. And then once you have a, you could find c. But this way is more direct. Might be a bit too clever. This is similar. Is this worth doing, or you think you're okay?
Pardon?
This question is similar. Is this worth doing, or you think you'd be okay with it?
Let me check. It's probably better if I do it.
Hang on.
Okay. So 5. Okay, so then we substitute them into the equation of L.
Yep.
So for the first one, it would be 7a plus b, open brackets, 5, close brackets, minus 12 equals 0.
Yep.
And then for the other one, it would be written out as 3a plus b, open brackets, 3, close brackets, minus 12 equals 0.
Yep.
And then you'd work it out, so it'd be the first one would be 7a plus 5b minus 12 equals 0. The second one would be 3a plus 3b minus 12 equals 0.
Mm-hmm.
And then you'd plus 12 on both sides.
Mm-hmm.
So it'd be 7a plus 5b equals 12, and then 3a plus 3b equals 12.
Mm-hmm.
And then would you put that into the calculator?
Yep.
So it'd be 7 plus 5 equals 12, and then 3 plus 3 equals 12. So x is minus 4, and y equals 8, so x equals 9, y equals 8. But in our case, a is minus 4, and b is 8.
Yep. Great. Any questions there?
No.
I suspect it'd be fine with it.
Mhm.
These are difficult questions, believe it or not. You're just destroying them. Okay, equation of a line.
Tick.
That's great. Equation of a line through a point. This strikes me as very similar. Now this will make more sense with the ABC thing, I think. Okay, how do we do this?
Okay. So could we? Should we sub in y equals 3x minus 9 first, or no? Into ax plus by plus c.
Let me see. The line y equals 3x minus 9 meets the x-axis at the point A. Find the equation of the line with gradient 2/3 that passes through A. So we need to find another line that passes through the same point. If we were to make those two, that would give us the coordinates of A. That will work. There's an easier way to find the coordinate of A. What do we know about the point A?
We know that it crosses the x-axis and that it intersects with the line with the gradient 2/3.
Yep. And so in relation to this line, the y equals 3x minus 9.
Yeah.
Any coordinate on A that we know? Anything about the
Would
point?
it? Oh, right. Okay. So it'd be. Well, we don't. We know the gradient, but wait. Would it be? So it'd be 9.
Just the point A, not any line.
Okay.
Anything we know about the point A in and of itself?
Would it be 3?
Yes.
Well, x is 3. It would be 3.
Yes. Y is 0, basically.
Yeah. Y 0.
And when you solve that, x is 3. Yeah, so that's a quicker way of getting the point. If you had subbed that into the other one, you would get x equals 3. Same way.
Yeah.
Okay. What is next?
So could we write that equation with the gradient 2/3 as y equals 2/3 x minus 9? Would that not be right?
It will be 2/3 x plus c.
Okay. And then we sub in. Could we sub in x, which is 3?
Yep.
So it'd be y equals 2/3 brackets 3 plus 6. And then you'd do.
Hang on. Where did plus 6 come from?
Oh, wait, sorry, plus c. Must have wrote it wrong.
What is y?
Y is minus 9. No. Wait, no. Wait, 0.
Yep.
So it'd be 0 equal. Oh, that's where the 0 comes from. Okay. 0 equals 2 over 3, open brackets 3, close brackets plus c. And then you do 2 over 3 multiplied by 3, which is 2. So it'd be 0 equals 2 plus c. And then you'd minus 2 on both sides, so it'd be minus 2 equals c. So c is minus 2.
Mm-hmm.
And then do we sub in everything?
Yep.
So it'd be, so, wait, so did we work out a?
Y equals mx plus c.
And then you substitute numbers in.
Yep.
So could you substitute minus 2 in
Yep.
as c? And
Yep.
then m would be the gradient. Does it matter which gradient you use? Or would it be 2 over 3?
Yeah, we want the line that has the gradient 2 over 3. Well done. However, they want it in this form, where a,
So
b,
you
c
minus
integers.
y on both sides. So it'd be 2 over 3x minus y minus 2 equals 0. Then you need to put it into integers.
Mm-hmm.
So you'd multiply it by 3, 2 over 3.
Yep.
2 over 3 multiplied by 3, which is 2. So it'd be 2x, and then you'd multiply everything else by 3, minus 3y minus 6 equals 0.
Hold on. Let's take a look. So they wrote it in the other way, so they'd only have 1 minus and 2 pluses.
Yeah.
But it's the same thing. So long as your y and c have different signs from your x. Yes, let's see. So you could have subbed the y into this to solve for, but it's much easier to say, well, it has if it meets at the x-axis, y is 0. So when y is 0, x is 3, so the coordinates of a is 3, 0. And then you just sub x and y and m into y equals mx plus c. You find c.
Yeah.
Sub all those in and rearrange.
Yeah.
Okay. Unless you have any questions, let's try this bad boy.
Okay. So for the first one, do you sub in minus 2 and 8?
No, because these lines don't go through B.
Okay.
They go through A.
So could you, okay, let me see. So could you write out 2x plus 3y minus 21 as 3y minus, no, 3y, well, minus 3y equals 2x minus 21.
And why would you do that?
Pardon?
Why would you do that?
Could you work out as a simultaneous equation?
Yeah. So, if you're doing a simultaneous equations.
Oh, you need x and y on both sides, don't you?
Yeah.
So you'd move 21 to 0.
Yeah.
So it'd be 2x plus 3y equals 21.
Yeah.
And then same with the other one. So you just minus y on both sides.
Mm-hmm.
So 4x minus y minus 7 equals 0. And then you move the 7 over. So it'd be 4x minus y equals 7, and then you put that into the calculator.
Yeah.
So x is 3 and y is 5. So is that the point where it intersects?
Yep.
So it'd be 3, 5.
Yep.
But it also wants it in the form ax plus by plus c equals 0.
You're not there yet. So
Oh, okay.
the point A is 3, 5. We want
So then can we use that to substitute it? Would you substitute that in?
If we substitute that into any of these, we'll just get C.
Okay.
We want the line that goes through A and B. So A is 3, 5. B is minus 2, 8. And we want the equation of the line that goes through.
So you use m equals y2 minus my y1 over x2 minus x1.
You can do it that way, yeah.
Okay. So m equals 8 minus 5 over minus 2 minus 3, which can you work it out? So 8 minus 5 over minus 2 minus 3. So m equals minus 3 over 5. So y equals minus 3 over 5x plus c. And then for y, do we substitute y, x and y? Do we just substitute any of the two coordinates in?
Yep.
So we just do 3 and 5. It's easier.
Yeah,
so
definitely.
it would be 5 equals minus 3 over 5 brackets 3 close brackets plus c, and then you'd work out that. So minus 3 over 5 multiplied by 3, which gives you 5 equals minus 9 over 5 plus c. And then you'd add, could you add 9 over 5 on both sides?
Yep.
Okay, 5 add 9 over 5. So it'd be 34 over 5 equals c, or 6.8.
Let's leave it as 34 over 5.
Okay. And then could we put that into y equals mx plus c?
Yep.
So y equals minus 3 over 5 plus 34 over 5.
And don't forget your x.
Oh yeah, x, yeah. And then they want it in that form, so we minus y on both sides. So minus 3 over 5x minus y plus 34 over 5 equals 0.
Yep.
And then we need to put them into integers. So since both fractions have the same denominator, does it matter?
No.
It doesn't really matter. Okay, so we just multiply everything by 5.
Yeah.
So minus 3 over 5 multiplied by 5. It's minus 3x minus 3y. Add.
Not 3y.
Oh, yeah, sorry. Minus 5y. And then add, and then it would be 34 over 5 multiplied by 5. 34 equals 0.
Yeah, and they probably wrote it as positive 3x, positive
Yeah.
5y, negative 34. Yeah, and 3x, 5y, minus 34 equals 0. And maybe because this simultaneous thing worked so well the first time. So for the first part, you did it simultaneously. I did the second part simultaneously as well. So we just have so we always have 1c, so it's like 3, 1, 5, and then minus 2, 1, 8, but whichever way you prefer.
Yeah.
This way is probably more understandable. Any questions about that?
Nope.
Just want to see what exam questions look like for this. Doesn't look like there are any. That's 5D. Okay, equation of a line through a point.
A tick.
Hey, this is fabulous. So we got through 3 things, and it's coordinate geometry, which most people have difficulty with. So next is parallel and perpendicular lines. Fair enough.
Okay.
Yeah, how was that for you, Adam?
That was great.
Any questions for me in general?
Nope.
All right, happy Halloween. I forgot.
Yeah, you too.
All right, talk to you next time. Take care.
You too. Bye.
Bye.